In this video, we will review transformations of parent functions of quadratic and square root functions. Let's begin with a quadratic function given in vertex form. f of x equals -1/2 times the quantity of x minus 3 to the second power plus 5. Before we identify the transformations, let's be reminded that the parent function of this vertex form is f of x equals x squared. And the graph is opening upwards. Notice that I labeled the distinct points of our parent function. Now let's list down the transformations of the given quadratic function, which is written in vertex form. Based on this vertex form, let's identify our a, our h, and our k. In our given function, a is going to be equal to -1/2. And this is going to be our vertical compression. In this case, since a is less than 1, when we start graphing it, it's going to be wider. And also, we see the negative sign in front of our a, so it will reflect across the x-axis. So the parabola will be facing down. Our h is going to be equal to 3. And this is going to be our horizontal translation. If you want to check, you can equate this to 0 and solve for x. So our x is really equal to +3, meaning we're going to have a translation of 3 units to the right. And here we have a vertical translation of 5 units up. So writing down all the transformations, we have vertical compression with a factor of -1/2, right 3 units, and up 5 units. So to do the transformation, first we vertically stretch our points by a factor of -1/2. That means the distance away from x is multiplied by -1/2. So multiplying all my y values from my original function by -1/2 will give me this new set of points. And now after plotting the points that are already vertically compressed by a factor of -1/2, I am ready to do the other two translations, the right 3 units and up 5 units. I'm going to start with the origin. So right 3 units, 1, 2, 3, and then 5 units up. 1, 2, 3, 4, 5. And now this next point, translating it right 3 units, 1, 2, 3, and then 5 units up. 1, 2, 3, 4, 5. And doing all the same translation for all other points, we'll end up having this set of points. And connecting all the points, here is the translated version of our parent function. And now let's have another example, and this time the squared function. So the squared function given is f of x equals 2 times the square root of x plus 3 minus 4. Here we know that the parent function is going to be f of x equals the square root of x. And then identifying the graph of our parent function with some key points 0, 0, 1, 1, 4, 2, and 9, 3. Now we are ready to identify the transformations of our given function. Similar to the earlier example, here our a is going to be equal to 2, meaning we're going to have a vertical stretch with a factor of 2. H is equal to -3, meaning we're going to move left 3 units. And k is equal to -4, meaning we're going to move down 4 units. Similar to our example earlier, if you're not sure about your h, you can equate this to 0 and solve for x. And then again, writing down all your transformations, vertical stretch with a factor of 2, 3 units left, and 4 units down. Okay, so to do the transformation, first we vertically stretch our points by a factor of 2. That means the distance away from the x-axis is multiplied by 2. In other words, I'm multiplying all my y value in my parent function. So 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. Plotting all the points who are already vertically stretched by a factor of 2, I'm now ready to do the other transformation, which is 3 units left and 4 units down. I'm going to begin with the origin, the 0, 0. So 3 units left, 1, 2, 3, and then 4 units down, 1, 2, 3, 4. Next point, 3 units left and 4 units down. Next point, 3 units left, 1, 2, 3, and 4 units down, 1, 2, 3, 4. Next point, 1, 2, 3, 1, 2, 3, 4. Now connecting all the points, and here is my translated version of my parent function. And that's it. And of course you can use your calculator to check. I hope this helps.